Okay, write my name, done. Number 1, write each as a mathematical expression. And again, every year catches more people than not. Unless you want to do 2 corrections. You go right, afterwards enter 8, signifying numerical or algebraic.
I did that.
Okay, because every year people don't know it. And then you're off to the bottom. Okay, so first 8 less than. So I'm subtracting 8 from something. 8 less than twice 6. So basically 6 times 2, I could represent it this way. I could put brackets, I could, whatever. But that is numerical. Half the length b, so I see a variable in play, so that's going to be algebraic there. Half the length of b times the height. So you could do this a couple different ways. Half the length is multiplying by half times the base times the height. It's the formula for an area of a triangle. You could have done base times height over 2. That would have been fine. Half is dividing by 2 or multiplying by a half, however you want. So this would be about it here, I think, for this one here. Okay. Number 3, write the word phrase as an algebraic expression. So algebraic expression, you should have a variable in there. J divided by 6. I sure hope you got that. The product of 12 and the sum. Hopefully you remember when you use the word sum, it means the answer to an addition problem. So the product means I'm multiplying. What am I multiplying? 12 and the answer of 10 plus r. That's what it would be. So whenever you see the word sum or difference, make sure you got your brackets. Vice versa. Write the algebraic expression as a word phrase. There's no order of operation confusion here. So I'd probably just say 9 times a number minus 3. You could say 3 less than 9 times a number.
Yeah, I did 3 less than 9 times a number.
That works, yeah.
I kind of overcomplicated it, but
Could.
it gets the point across.
Oh, what did you want to do?
So this one here, I would probably just, again, you could do this one a variety of different ways. There's no order of operation confusion again
You have to
here.
have some.
No,
Okay, good.
no, I don't, because if I wrote it out this way, I would still do divide before. So I could just say 15 plus a number divided by 2. I could say a number divided by 2 added to 15.
I did the quotient
I could
of
do-
10 and 2 added to 15.
Yep.
That's exactly what
I wrote down here 15 increased by half a number. So,
Very basic.
okay, good with that. Combine like terms, same variables to the same power. So for this one, there's my like terms right there. They can be combined. What do I have? Negative 2n squared, positive 11n squared. Negative 2 plus 11 is negative 9. Label doesn't change. And then what do I have left? Well, minus 4n. That can't be combined with the other ones. It is the same letter, but not to the same power, therefore not like terms, therefore cannot be added or subtracted together. This one, I need to distribute. So this one, again, a little tricky in the sense you're essentially distributing a negative 2 into the brackets. So if I multiply, I got 4c over here, right? Negative 2c times positive 14 is negative or subtract 28c. Negative 2c times positive d is negative or subtract 2cd. So multiply both terms by negative 2c. And then this is your thing. Here's your like terms to combine. 4c minus 28c is negative 24c minus 2cd. That term can't be combined, but that CD term only shows up after you distribute and remove the brackets. Do you see the CD terms even a term for you? So you got to just always got to clear the brackets out first. You'll get lots of practice with this in Chapter 5, lots and lots. And you'll learn that this can be simplified further too, by the way. And it will. You'll start simplifying more. More simplifying, Sam. This is not simplified. Can you believe it?
Okay.
It's truth. The actual simplified answer would be this. That would be the simplified answer. Simplified! And once things are simplified, we like that. But that's Chapter 5. You'll learn that. Coming. Day's coming. Evaluate. 7th grade. Damien. Number 9, just plug it in with a calculator. I can't believe this will be too hard, but make sure, again, if I was subtracting y, that would be like a double negative situation there. Sometimes when you're subtracting a negative just disappears in the wind. 20 minus w, which is 1, so that's 19 times negative 4 equals negative 76.
Oh. Wait, no, I got that right.
3, well, I would hope so. 20 minus 1 in first is 19. 19 times
I saw
negative
you put
4.
the 20, and I was like, I thought I got it wrong. But
Right.
then you put the negative minus.
I mean, with a calculator, too, it would just be like,
Yeah, I got it right.
what has happened here? So now plugging in y, negative 4, multiply 4, add 3 times negative 4, negative 12, plus 8. That gives me a negative 4 on top. On the bottom is a positive 20. That's negative 1/5 or negative 2/10.
Oh, I
Fine.
didn't do negative.
Yep, negative. Negative 4 on top. Positive 20, so negative. Negative 1/5 or I don't care which way you did it. One of those two. Which equivalent is equal, so basically I'm saying solve here, plus 7, y equals 10. So which of these 4, when I plug y equals 10 into it, is true? And that would be that one. If I plug 10 into these other ones, I do not get the right answer. So figure out what y is, then figure out which one it applies to. Good. Great. Next page. Right, is an equation. Boso's allowance. It's 3 times Maya. So I don't know what Boso's allowance is. I don't know what Maya's allowance is. But Boso's allowance is 3 times Maya's. So Boso equals 3 times Maya's. Boso's, don't know what it is equals 3 times Maya's. 3/4 of a number is 24. So 3/4 of, when you see of in fractions, that means multiply. So 3/4 times a number is 24. Oh, do not have to solve. Oh, just stretching. Okay, here we go. Now to the nuts and bolts of this thing here. How'd you guys solve this? Did you add the variable first or multiply by negative 1?
I'm not sure.
The first one. I see subtracting p, so that means either I need to add the variable to both sides at the beginning or multiply by negative 1 at the end. Well,
I think I multiplied by negative 1.
that's would be my preference, and that's what I'll do then. Okay, well, it's good we're so on top of that here. But either way, when you're subtracting a variable, either you add it to the start, I'd have p plus 12 equals negative 9. But if I do it this way, that's negative p, so then multiply by negative 1, all the signs flip, p equals negative 21. If I would have p plus 12, subtract 12 from both sides, 9 minus 12 is negative 21. 9 minus a negative 21, double negative. 9 plus 21, which is the same as 21 minus 9, is 12 when I test it. 15. Subtracting fractions. So answer should come back in a fraction. 2, 6, that's 7, 6.
7, 6, 11, 6.
So close. Simplify. I'm just assuming you know how to simplify that. I don't need to walk through the steps.
I
Right. 6 minus 2 and 1 4. 6 minus 2 is 4. And 3 3/4. I could mental math that one there. So 4 minus another 4, 3/4. Maybe you can mental math it too. So I would combine those terms on the left. Now solve minus 2 and 2/4. Again, just speeding it up a step. I get 1 and 1/4 equals B. 3 3/4 minus 2 and 2/4. 17. Divide both sides by 18. You have a calculator. Negative 135 divided by 18. Decimal's fine. Or 1/2, of course. Negative. Negative divided by a positive. Negative outcome. 28. Do the opposite. Multiply both sides by negative 1 and 25/100. 2 negatives makes the variable positive. 2 negatives, positive outcome. Punch it into your calculator. B equals 12. Negative 9 and 6/10 times 1 and negative 1 and 25/100. Positive 12. This one here, again, I'd combine like terms. That's 6/8. I'd simplify it and just call it 3/4 equals 2a. Dividing by 2, which is the same thing as multiplying by 1/2. 3 times 1, 4 times 2, 3/8. Right. So combined, 6/8. I wrote it simplified. Dividing by 2 is the same thing as multiplying by 1/2. Getting comfortable with those types of arrangements is really useful because see how I can just write it out and just boom, solved real fast. When you think about it that way instead of dividing by 1/2.
Were these the questions I was doing bad
Huh?
on? Is this the kind of question I did bad on?
It's more common. I'm kind of powering through these first ones here. 20. Combine like terms, 5D and 3D, or negative 3D, or however you want to see it, but 5D minus 3D is 2D. Minus 3 equals 4 and 2/10. It's a two-step equation. Add 3 to both sides. 2D equals 7 and 2/10. Divide both sides by 2. D equals 3 and 6/10. Another two-step equation, but kind of weird. Y is in an inaccessible spot at the moment here. So really the only thing I can do is, again, most two steps, you're going to do adding and subtracting first and dividing, but I have to get rid of this division first because I can't even get to the y. So the first thing I'd want to do is just multiply everything by 7 here. That cancels out. I still got y plus 3, negative 2 times 7, negative 14. And then it should be easy to solve from here, I hope. Y equals negative 17. So it's just making sure you do this step first because your y, you don't want to subtract 3 first. Otherwise you'll have negative 5 and you'll never get to 17 anymore. So you have to do it in this order because the y is not accessible. I can't subtract 3. It's basically 3 sevens in a sense, so subtracting 3 from it's not even the right number, right? Okay. Next page, 22. Distributing. So, like we've talked about many times, you always got to clear out brackets before you do the solve. Pre-game work. Never ever start trying to solve when there's brackets still in the equation. They have to go. Always. 8 times p is 8p. 8 times 7 is 56. It's a two-step equation. I guess in a sense it's 3 because I had to distribute first, but once I do that, then it's just solving another two-step equation. And that's not a problem for any of you. So negative 24 equals 8p, divide both sides by 8, p equals negative 3. This one, I guess you have a choice here. You can certainly combine these like terms first, or you can multiply by 3 first. Really, both of them gotta have, the order you do them doesn't matter. Personally, I'm gonna combine the like terms on top first. So this turns into 3k 6. I can't get to the k at all because of this here. I just chose to combine like terms so I could only write 2 numbers instead of 3 numbers a few times. That's why I combine like terms first. Savannah, what are you doing? What are you up to?
I was gonna click on a tab.
Oh, okay.
I was getting on the.
It's good I was able to help you. So this is similar now to this situation where there's only one move here I have at this point. And that would be to multiply everything by 3, because I have to get rid of that before I can even get to the k. So now, where am I at? 3k plus 6 equals 33. Now it's a 2-step equation. So if you got the 3k plus 6 equals 33, most likely you've sailed your way home. It's the getting to this part. If you got here, but again, you can choose to multiply by 3 first, or you can combine like terms first. It really doesn't matter. Both those things happen first, and the order you do them won't change that this will be where you will be. Okay? So then just solve it, subtract 6, 3k is 27, k equals 9. K is 9. 24, variable on both sides. I could subtract 6c from both sides, or I could subtract 8c from both sides. It does not matter. Personal preference,
6.
subtract the 6, me too. I like positive as much as possible. So what I've done here is I've gotten the variable on one side of the equation. I'm never going to figure out what c is if it's literally on both sides. It has to get on one side. So rewrite 7, 8c minus 6c is 2c minus 13. There's your 2-step equation. Add your 13. 2c equals 20. C equals 10.
I'm not doing the same steps you are, but I'm getting the right answer, so, you know, it is what it is.
Okay.
Not exactly sure how I'm getting the right answer, but I am.
Well, if you want
I-
to
I-
elaborate,
No,
I can
I
help.
see the 2c equals 20. I just,
If you subtracted 8c, you might have had negative 2c plus 7 equals negative 13.
oh no, I just wrote a different number. I had 2c minus 13 equals 7. I just wrote it backwards.
Oh. That's, yeah, if you have 2c equals 7, some people prefer to rewrite, and they like
Yeah.
operating with the variable on the left-hand side. So that's, if you just rewrote it that way and solved it, that's fine. There's nothing wrong with that at all. So there's,
Is it coming to you?
you wouldn't be the first that has to rewrite and wants the variable on the left. There's a number of people that do it that way. When it gets more complex, I will do that too. But yeah, there's absolutely nothing wrong with that. 25. So the way you're going to solve, you could use the greatest common factor method if you wanted. I could multiply this whole thing by 12, right? But you can also use cross product. So if you liked using the greatest common factor method, and you'll use it here on 26, that's the one you got to use it for. You could use it here. Multiply everything by 12. I'd have 3n plus 3 equals 6n minus 6, or minus 3. That would be the equation. If I did the greatest common factor, and then just, but personally, that's not my favorite method. Greatest common factor method doesn't always work. Cross products, though, always works. So you should use cross products. So basically I'm saying 6 times n plus 1. 6 times n, 6n. Positive 1 times 6 is 6. So there's one equation. Did you guys use cross products here?
Yes.
Yes, as I would too. 4 times 3n is 12n. 4 times negative 1.5 is 6. So this would be my equation if I used cross products. And then it's a matter of just solving the same way. I'll just do it this way again. I'm assuming if you did it the other way this way, this is probably what you did. So then I have, there's my two-step equation now. 6 equals 6n plus 6. Add the 6. 12 equals 6n. Divide by 6. N equals 2. N equals 2.
Did he?
Greatest common factor method. I think I said this is the one. Again, I'll identify, and then I'm going to walk through a decimal one, at least one with you. So when I'm saying the greatest common factor method, you could have used it here. I said you could have multiplied by 12. But what I need you to do, and you seem to know what you're doing, you seem less certain of how this works, so pay attention. 2 times 2. First, I need to write them in improper fraction form. This one, if I want to put it over 1, then so be it. Doesn't matter here. But I need to get everything in improper fraction form first. What I'm asking myself is, what is the greatest common factor between all these numerators? Hopefully you're saying the answer is 8. So what you need to do is then multiply basically all 3 terms by 8. What you're trying to do is rewrite this without any fractions, with whole numbers only, and then solve a pretty simple, instead of with all this fraction and half this and that. So if I multiply everything by 8, I'm going to write it 3 times because this term, so these cancel out. So now I just have m on top, right? Over here, again, you can think about it this way. I could cross simplify. That's a 1, that's a 4. On top, I have 5 minus 4. I have m minus 20. And then over here, times 1, so just I have equals negative 32. And I got there by multiplying all 3 terms by 8, the greatest common factor. This is what I would look for here. On this problem, I would have to see some evidence of you multiplying by this to get to here. That's what I need to see when I say it. So again, solving that, yep, then you'll solve it, and I realize you can solve it with the calculator in the first place here, but the lesson objectives are very specific here that you are to utilize this method.
I didn't even notice, and I just did it like normal.
I just, like, before.
Solve multiple involving decimal fractions. Okay, using variables in denominators. So
Yeah, I just didn't even notice that it was like a one of those.
Right. Yeah, and that's fine. I'll tell you on the test. It just so I won't. You guys will know what problem you have it for. So, won't be a-
My negative 4 just disappeared.
but I just need you to show me that all these others you can serve. And I told you on this one here, just very, hopefully briefly, I said you could have did it here too, and I was right. I could have multiplied everything by 12 here because that's a 1, that's a 3. I get 3n plus 3 on top. Multiply this by 12. So that's a 1, that's a 2, that's 6n minus 3. This one right here, multiplying everything by 12, it's the same thing. And then I could solve it, subtract, I would have 3n minus 3 equals 3, add the 3, 6 equals 3n, n equals 2. N equals 2. But this would have been my equation here if I just multiplied all this by 12, right? I would have, personally, I'm saying I would always use cross products though if I can, but if it's specifically saying, I mean, this is one where I could go either way, I guess, but it's, you won't always end up with these wonderfully beautiful numbers like this on the bottom here. You'll get weirder numbers that you won't be able to simplify anything, and you'll have to use cross products. Always works, right? Always works. So you have a general idea what I'm trying to do here with these. We can practice them over recess again if you want, but this is another one where I could, in theory, multiply everything by 8. I just have negative y over here, and on this side, I'd have 14 plus 6y if I multiplied everything by 8. But I'll use cross products. I could, maybe you did. You can make your own choice there. I won't work it again, but literally, if I multiplied by 8, my equation would have just been negative y equals 14 plus 6y. That's if I multiply everything by 8. This would be my equation. This would be my equation if I use cross products. Both of them will get me the same final answer. So here, I would subtract the 24y because otherwise I don't have anything at all on the other side. So I'd have 56 equals negative 28y. Y equals negative 2. 56 divided by negative 28 is negative 2.
I think it's the process wrong, but I got the right answer.
I think it was the other way around here. I think I did the process right. with
You might have added and had nothing and then subtracted and ended up realizing I gotta bring something and subtract it and then switch the 56 back over.
Oh, wait.
You could have did it that way. It wouldn't. But, yeah, if you get negative 2, then I like how you did it. Okay. These are favorites. 28. So 0.87 with both repeating. So this is with everything repeating here, ready to go. So write my first equation, whatever it is, it is. Right? The second equation, 10 to the d power, where d is the number of repeating decimals. In this case 2, 10 to the second power is 100. Multiply this by 100, I get 100x equals 87.87 repeating. Subtract the first from the second, I get 99x equals 87. Divide both sides by 99, I know it divides by 3. Sum of the digits, so that's 29 over 33.
Yep.
Where I need to stay, I think so. And easy to check. Take your numerator, divide by your denominator. Boys should get, there it is, 0.87. And obviously, this is just a rounding thing here. It doesn't turn into a 9 all of a sudden. It just rounds the final digit. So
Yeah, it does that with
it's limited with your, yeah. Yeah, that's just how calculators function. It's not that this end, most people have the common sense and wherewithal to understand that situation, but still, that's actually an 8 there. It's not a 9, it does repeat. Okay, other one with just the 8 repeating. So first, you can set up your little equation again. So this time, they don't all repeat. Our first move is to get the decimal. So it's immediately to the left of wherever it is going to repeat. Same deal, 10 to the d power. How many spots do I got to move it? Looks like 2 spots. That's multiplying by 100. 100x equals 4.8 with the 8 repeating. And then, just like the other one, multiply by 10 to the number of repeating decimals. There is 1. So multiply this equation by 10. 10 times 100 gives me 1000x, and this gives me 48.8 with the 8 repeating. Subtract the 2 from each other. I get 900x equals 44. And then that's 22 over 450, 11 over 225.
That's somehow got that. I'm not exactly sure how it did it.
11 divided by 225.048, and there's the 8 repeating away out there. So 11 over 225. And I could have checked it at 44 divided by 900 if I wanted. Yep, there it is. These are all equivalent fractions I wrote here, so they all have the same decimal value. Savannah, do something else.
I'm just listening.
Okay, fair enough. You got your thing. All right, continue, Savannah. Listening. Okay, good with that?
Yeah.
Okay, I'm gonna do one with a decimal here. Real quick. I gotta make sure you know how to do it. I'll just do this one here. You did it in your homework. Okay, great. 0.09D. And I'm showing you this because for some reason there's no decimal here. I didn't look at the test. Hopefully there's a decimal. But if this is a D, there's your variable, D. Okay? So 9 hundredths D minus 14 hundredths equals 67 hundredths. I would say you, I didn't even notice that. I was so in the zone, right? 6, 7, right there. It's 6, 7, 6, 7. It happened.
Do the side, do the side, do the video.
6, 7, woo! 6, 7. Right?
7.
I was so in the zone, I totally spaced. I didn't even notice. But. Anyway, we'll have a few more opportunities to talk 6, 7 this problem, but showcasing the method here. The method is, I want you to just like kind of like the greatest common factor thing. You multiplied by this magical number and all the fractions just lifted themselves away and I was left with a no calculator necessary type of problem. Same thing with these decimals. How do I do it? What do I want to do? So you're multiplying by the power of 10 to clear the decimals. So I count all the decimal spots. This one has 2 decimal spots, this one has 2 decimal spots, and this one has 2 decimal spots. So I always want to multiply by the power of 10 to whatever decimal value had the most decimal spots. So in this case, they all have 2, which means I should multiply by, no, 10 to the 2 power is 100. So I multiply all 3 terms by 100, but what happens here is when I multiply by 100, it just moves the decimal 2 spots to the right. So this goes 2 spots to the right, now I got 90. This goes 2 spots to the right, now I got 14. And this goes 2 spots to the right, now I got 67. There it is, 6, 7, 6, 7, it shows up again. I forgot again some of them. So add 14, 90 equals 81, D equals 9. One more very briefly, just to make sure you can do it. So if I had this one, 0.06 N minus 3/10 equals what am I even, negative 21 hundredths, cool. Solve it if you want, but what would I multiply by? What would my new equation be?
100 and it'd be 6.
Oh, you could just give them. I know you got this. These two both. Mastering it, so to say. But if you can rewrite the new equation without the decimals.
Let it be 6n minus 30 equals negative 21.
Right. And that's this one I just wanted to make sure because I got 2 decimals, 1 decimal, and 2 decimal. You always multiply by whatever value has the most decimal spots, right? Because you want to get rid of the decimals. So if one has 4 and the other have 1, well then multiply by 10,000. You won't have anything like that, but multiplying by 100 is the key. We need to move it 2 spots, so there's the 6, but right here, 1 is a 3. It's up to you to add that 0 in yourself. Minus 30 equals negative 21. Right. Okay. And then the answer would be 1.5, by the way. 1.5. But this would be what I would look for here. And then the right answer, of course. But when I say show me the process, I need to see this equation. Does that make sense? What I need? Right. Okay, these two I just did on the other sheet of paper. Absolute value equations. So absolute value equations will have 2 answers. I always want to resolve anything outside of the box first. That's in 31. Once everything, the operation and all that, whatever I got to do is inside the box, then I can start solving this. So it's just 2 equations. one equals to 5, the other needs to equal to its inverse, or its opposite. So solve the two equations, add 7 here, r equals 12. Or, if I go over here, add 7 to both sides, -5 plus 7 is r equals 2. 12 minus 7, positive 5. 2 minus 7 is a -5, but it's in the absolute value box, so therefore it becomes positive 5. This one, again, you got to get this minus 3 has to go because it's not in the box. So I have to add 3 first. And then this is still in the box, but there it is right there. Now I can solve the two equations. 3m minus 7 equals 11. 3m minus 7 equals -11. So you have to resolve everything outside of the absolute value box first before you rewrite your two equations and solve the two equations. So then add 7 to both sides. 3m equals 18. M equals 6. Or add 7 to both sides, 3m equals -4, divide by 3, that's -4/3, simplified, -1 1/3. I'll write that one a little bigger if you didn't catch what I all did there. But I added 7 to both sides, this is the second equation. So I have 3m equals -4. And then I divide both sides by 3, m equals -4/3, but we would simplify that to that. So m equals 6 or -1 1/3 are the two answers. And again, you can test them on your own. I could probably test the 6 real fast. 18 minus 7 is 11, minus 3 is 8. Boom, you test the -1 1/3 one. Solve for the given variable. Don't need to actually solve anything here. I'm just saying rewrite in terms of x, right there. So what does x equal is what I want to know. So looks like there's two different things going on to x. I'm adding b and multiplying it by a. How do I do that? Subtract the b, divide by the a. So subtract the b from both sides. That gives me ax equals c minus b. And then divide both sides by a, which basically means that's it right there. C minus b over a. So first thing I did, subtract b from both sides. So I got rid of that. So then I just have ax equals c minus b. No like terms or anything. And then last thing I'm doing to x, multiplying it by a. How do I do that? Divide both sides by a. Boom. X equals c minus b over a. 33, writing for d. So first thing I do is get rid of this 2z, 4z thing. I'd subtract 2z from both sides. So 4z minus 2z is 2z equals bd. And then all I need to do is divide both sides by b, which means there it is, right there, 2z over b. It's kind of fun to say.
Yes.
2z over b.
2z over b.
2z over
With
B.
a d. D equals 2z over b.
The D.
2z over b.
The E sound, getting a workout.
Equals D.
Lifting with E. E. E.
The video is
People are going to think this is an ELA class. Heavens to Betsy's.
6, 7.
Right. 6, 7. 6, 7. You should, and if it was the real test, I would want you to write the equation, then solve the equation. So I will remind you of said matters tomorrow, but yes, we should be able to represent this as an equation. The temperature today is 2 more degrees. So I'm adding 2. What am I adding it to? Twice yesterday's temperature. So twice yesterday's temperature plus 2, it is equals 10. There's your equation.
Trying to get that.
Subtract 2 from both sides. 2y equals 8. Divide by 2. The temperature is 4 degrees. Nice work, Faith.
Oh,
Right.
4 degrees. Yeah, I did get that.
Well,
I thought you
you'd
said it was
also
10
need this
Oh, I didn't get that part, but
To get-
I did get 4.
to avoid. Then I would write correct answer, missing equation. You've seen that before.
Take half of one away, or would you take
It's
all
a
one?
you do a correction on it.
Oh.
Correction incoming.
Technically, yeah,
Need an equation, right? No doubt about it. The equations can be challenging. This one's easier than 35's equation, I think.
Yeah, it is.
For an overdue book, the Spooner Library. 7th grade. Shh. For an overdue book, the Spooner Library charges a 25-cent
Is that
penalty.
true?
Plus, I have no idea.
Your mom should know. Ask her.
My mom would know. Plus 5 cents for every day the book is overdue. Okay? The Shell Lake Library charges a 5-cent penalty plus 10 cents for every day the book is overdue. For what number of days is the total fee at both libraries the same? This is variable on both sides because it's going to be like a two-step on both sides. So let's start with Spooner Library. Okay? It says that it charges a 25-cent penalty, so that's like a flat fee. 25 plus 5 cents for every day the book is overdue. So 5 cents times however many days it's overdue plus the 25-cent penalty, right? And then it says, well, what day is it? So they're the same. Is equals. So the Shell Lake Library, a 5-cent penalty. So that means I'm adding 5 cents here, but 10 cents, 0.1 times the number of days for every day that it's due. So however many days it's Spooner, it's times 5 cents, but then we're adding a flat 25-cent fee. Shell Lake, we only have a 5-cent fee, but we're going to charge you 10 cents a
I
day.
feel like this is one of the times where you move the decimal.
That is a great strategy. I would multiply by 100 right away, because then I'd have 5D plus 25 equals 10D plus 5. Now, we can go ahead and solve it as we would any other. Subtract 5D from both sides. 25 equals 5D plus 5. Subtract 5, that's 20 equals 5D. It would be 4 days.
Yeah, I didn't do it like that. I wrote it on
So,
the chart.
and you can think it through. 5 cents a day is 20 cents plus their 25 cent, that's 45 cents you owe them. Here, 10 cents, 4 days is 40 cents plus the 5 cents, 45 cents on day
Yeah, I
4.
wrote it on a chart, but I got the right answer.
Cute, but
Cute.
Mr.
Cute,
Walker called me cute.
very cute, Sam. Very good. I appreciate. I don't know. Maybe I give it to you with the effort there. I don't know. It would
Do I
depend
give
on
you
my
for effort?
my
Pay
mood
for
at the
effort.
moment, but ideally, this is what I would see. I'm not saying it's easy to generate that type of equation. It is not. I'm not telling you it's. Oh, obviously, it's this, and clearly, it's that. I mean, why don't you realize there's a variable on both sides? Come on.
You should buy.
I can't believe you guys. How are you ever gonna go to high school?
You need more 6, 7.
Yeah.
6, 7, right there, 6 lines. That's 5, 6 lines. Now I'm gonna draw 7 lines. 7 lines. 6 lines, 7 lines.
41, Mr. Walker, 41.
Maybe I'll be gone in like 15 years. And I'm like, this looks good, time-wise, sounds good. You know, play this for our class. After Juliana's done with school, they'll be like, what are they doing?
What is 6, 7?
Listen,
Why-
they're not gonna.
why-
No, then we'll bring it back. We'll
They'll,
bring it
they'll
back.
go, why is my dad yelling 6, 7?
No, then we'll bring it back.
Why is my mom and dad yelling 6, 7?
6, 7.
Ah!
Imagine trying to explain that.
This may or may not actually happen in